Hi guys, welcome to another video. So I'm Charlie and this is Vamos Gaming Systems channel. This is an older recording of a build that I did for a customer. It was, I believe, roughly about 1,500 Singapore dollars gaming PC build, and we did it about at least a month or two ago. But I recorded the footage, but I just didn't I forgot to make a video about it, so might as well since I have the free time now. So basically what's in this PC is that if I remember correctly, we have 7600 as well as 32 gigabytes of DDR5 RAM, should be 6000 CL30 or CL36. The GPU is a 9060 XT, 16 gigabyte. I believe, is it the Reaper version? I can't remember the full specs. It's in my phone somewhere, but my phone is being used for this recording, so I can't refer to it. But I believe okay, most of the parts I actually bought from Dynacore. So I think we took the bundle whereby the CPU is a 7600, which is a 6-core 12-thread Ryzen 5, and yeah, so along with the motherboard, I think it's an ASUS Tough gaming. It's something like, I think it's a looks like a B650M-E Wi-Fi, if I'm not wrong. I don't have the specs with me at the moment. Maybe I'll update it in the video description later once I go through my my previous contacts and all that. Okay, SSD, I believe we went for a 2 terabyte NVMe SSD, should be the Adata Legend. Yeah, which is not too bad. Then RAM, we have I think this is a Crucial Pro, should be 6000 CL32 or CL36. I can't remember the exact cache latency, but it was pretty affordable. Oh, okay, so we have the motherboard here. Is the motherboard is the Tough Gaming B650M-E Wi-Fi. And all in all, this build was pretty affordable, coming in at about around 1,500 SGD, and it was built in the Lian Lancool 207. I actually gave the client is not that into computers, they're not that into research, and most of the clients who approach me, yeah, they're not super into computers, so it's my job to give them some recommendations based on what they want, right? So he mentioned that he actually doesn't have any specific needs for it. He is gonna use it for a little bit for his work, but mostly he wants to build a system for pretty light gaming, so to say. So he doesn't have any video editing requirements, he doesn't have AI requirements, just some light videos, light gaming. And I asked him what are the games that he wants to play. He says he's probably interested to try Monster Hunter Wilds. So when I heard Monster Hunter Wilds, it is a pretty VRAM intensive game. I was like, okay, we need at least a 16 gigabyte VRAM card. The other options would be the 5070 from Nvidia with 12 gigabytes of VRAM. That would maybe be okay, but in terms of longevity, because most of these clients who approach me, they actually want their PCs to last for a decently long time, at least maybe 3 years or even 5 years before their next upgrade cycle. So something with a GPU with at least 16 gigabytes of VRAM should be able to last them for that long period of time. Obviously games are going to be more intensive, but they can always with that additional VRAM, they can always run it at higher settings, but maybe lesser FPS based on the speed of the GPU. So as you can see in this video, actually I'm moving my hands and so on, because as I'm building this video, as I'm doing the build, I'm sort of explaining the build process and the parts to the customer, so as to educate them as well, because yeah, that's what I like to do. I like to educate the general audience, such as yourself, whoever is watching, on how to build a PC, and yeah, what parts should we choose and things like that. So right now, even before we get the case in, I'm actually building it outside of the case. So this is what I like to do. I like to put in all the parts for let's say the RAM, the CPU, the GPU, sometimes even the SSD, but mostly SSD is not really required for a boot test. And then I'll connect the power supply and do a boot test outside of the case, so that to check if all the parts are working, whether yeah, whether they are working. They should be compatible with each other, but just that whether they are working. If there's any so-called faulty parts, at least we test it outside of the case, because if we put everything into the case and you put all the parts together and your system doesn't boot, then that will be a huge issue. You'll be like struggling to get the motherboard out, struggling to get GPU out and everything like that. So yeah, so I assemble all the parts and do a boot test outside of the case. So let's see if maybe you can speed this up a little bit. Yep, I'll speed up to 2x and probably fast forward it. Yep. So I'm explaining the build process to the client here. Obviously, this is the client's home, and we're not going to show his face because he asked to not show his face for privacy reasons. I mean, yeah, try to just forget his face. Okay, we can't really see it. So explaining that for the RAM slots, you can see that there are gray and black RAM slots on this particular ASUS motherboard. So how do you remember which RAM slots to populate first with 2 of RAM is the guideline I always use is imagine that you want to give a little bit more space for the CPU cooler to breathe. So if you need more space for the CPU cooler to breathe, you need to populate the RAM slot that is 1 slot away from the CPU. And if your CPU comes with 4 DIMM slots, because these slots are called DIMM slots, if it comes with 4 DIMM slots, you have to populate it in an alternate manner. So it can't be like the first and second slot, because that would mean that dual channel memory doesn't work. So in order for dual channel to work, you have to populate them in alternate slots, like the second and fourth slot or the first and second slot. In many cases, for most motherboards, the first slots that you need to populate for the PC to boot properly is actually the second and the fourth slot. So just think of it as you need to give the CPU cooler space to breathe. So populate the slot further away, one DIMM slot away from the CPU. Then next we put in the CPU. So I'm explaining that the arrow have to align with this top part here. There will be a small golden arrow like indicator on the top. So just put your then there will be this on the PCB of the AM5 CPU. There will also be a golden arrow. So let me fast forward, backtrack a bit. So maybe I'll use Epic Pen to illustrate it a bit easier for the startup. Okay. So at this top corner here of the PCB, there will also be a golden arrow. So this golden arrow is for you to point towards, there will be a sort of like a silver golden arrow on the top of the AM5 socket, top left of the AM5 socket. So this is for you to align, make sure that the CPU is aligned properly with the socket. So you just gotta align the arrow on the PCB of the CPU to the arrow on the socket on the AM5 motherboard. So it will usually be on the top left. So it's there's an arrow here, and then there's an arrow on the PCB here. Okay, so once it's lined up, then you can proceed to so-called lower down the retention bracket. And then there's this lever that you press down to secure it. So notice that there's this tough plastic, there's this tough logo plastic casing covering. You do not need to remove the plastic case before so-called lowering the lever. The plastic case will usually pop up by itself. The plastic is important because since there are pins on the socket of the motherboard, you don't want any accidental presses of the finger, or if you drop anything into the socket, it's going to damage the pins. So the plastic is meant to protect the pins. Okay, and I remember like at Dynacore, even the seller who sold us the motherboard, because I was going to assemble it myself, he also unboxed the motherboard and before selling it to us, and then he showed me the motherboard pins to let me get a visual check that yes, when we sold it to you, all the motherboard pins are not bent, it is in perfect condition, so we can't complain, right? Because some customers will actually make the mistake of bending the motherboard pins themselves by improper installation of the CPU, and then they go back to the shop and complain that, oh, you sold us a motherboard with bent pins. But that is usually not the case. Most of the time, the motherboards usually come with perfectly okay pins, usually user error that bend the pins, but there are some rare instances whereby, the motherboard pins does come bent from the factory. So the Dynacore seller was like, hey guys, now I'll let you take a look at the pins, so you see that it's all in perfect condition when I sold it to you. Okay, so you verified it, and then they will then we'll make the payment for it. So that's to sort of like steer away from complaints. So CPU is in. Next up, we're just gonna put some we're gonna install the NVMe SSD. So NVMe SSD, there's this so-called heatsink. So I use my so-called automated screwdriver to remove the screws on the heatsink. This one I can probably forward a bit. Yep, so you can see that SSD slots in here. So this is the 2TB Adata, I think Gen 4, should be 5,000 or 6,000 megabytes per second transfer speed. So you slot it in, then you press down, and on modern motherboards these days, there's this kind of plastic retention clip that you can just rotate, and it will secure the SSD in there. Then you gotta put the heatsink back. Make sure to remove that so-called, there will be a plastic that protects the thermal pad. So remove that plastic from the thermal pad so that the thermal pad can have good contact with the chips on your SSD to conduct the heat away from it. Then we will just screw it back down. Okay, so screw back the screws, and the SSD is fixed. So you can see that there are two slots on this B650M motherboard. Usually for SSD, if you're, especially for your operating system, if you only have one SSD, always run it on the top slot. That's where you get the maximum amount of PCIe lanes. Rare instances whereby the top slot doesn't get the max PCIe lanes are, I think there was another ASUS motherboard that I worked with in the past that didn't get the max speed for the top slot. It was weird, but I think with BIOS updates and stuff like that, it was working properly. So it was weird. Just out of factory, the top slot didn't run at the max speed. Okay, so moving on. So I'm just doing some. Okay, so we're unboxing the CPU cooler. I believe this is the very standard Peerless Assassin CPU cooler. It is, air coolers are cheap nowadays, especially from Thermalright. I believe this only costs, I think, about 42 to 45 Singapore dollars from Dynacore. So it's a very affordable CPU tower cooler, right? Because an AIO, I think the cheapest AIO also comes from Thermalright. They would cost about at least 90 to 110 Singapore dollars, so about double the price. So about half the price, you also get sort of like similar levels of cooling performance. I would say this one probably loses by about maybe 5 to 7 degrees Celsius compared to a 360mm water cooler, but it is not that bad, right? The good things about air coolers is that they are cheap, they are reliable, because air coolers run on just two tower coolers basically run on two fans, and if your fans fail for any reason, basically heat is still being dissipated away by the heat pipes on the heatsink, and as long as you replace the fan, they should be fine. And even if one of the fan fails on this tower cooler, you still have the second fan because you have two fans. So it's only in the rare event that both fans fail do you need to actually replace the fans. So CPU tower air coolers are super reliable. Like we have a lot of comments on the internet wherever I make videos and I look at other tech videos. There are a lot of comments from users that mention that, oh, I'm still using my Noctua like D15 or something like that, one of the goated CPU air coolers of all time, and they've been using it for like 10 years or something. So yeah, air coolers are just super reliable and very affordable as well. So taking out the brackets for the air cooler, these are red brackets are usually for AMD, and they have I believe blue brackets for Intel systems, so like Intel chipsets. And for AMD, it's pretty convenient. You just take out the red, so-called the red spaces, and then there is a AM4, AM5 labeled metal bracket. Then you will need to remove the plastic. So I'll probably show it in the video later. Yep. So in this case, I apply thermal paste here. Thermalright tower air coolers come with, I think, a very small amount, maybe like 1 gram of TF7 Thermalright thermal paste. So that is enough. In this case, I forgot to bring my my standard thermal paste to the client's home, which is, I believe I use a Mac Store standard thermal paste when I repaste my GPUs. Yep. So it's pretty fortunate that the air cooler comes with some included thermal paste. So here actually I found that the thermal paste was a little bit hard to spread. So I actually sort of like asked for a toothpick from the client. So he managed to get a toothpick for me, and then I used the toothpick to better spread the paste out. So since we don't have like a spatula or like a good spreading tool, I just use the toothpick to spread most of the paste around. As long as there's somewhat even distribution on the CPU, it should be fine. So we did do I do remember we did do a like a CPU temperature test after booting, and we did some stress tests and so on. The temperatures were okay. Okay, so that was doing more explanation to the client. I'll just forward a little bit more. Okay, so have I already removed the bracket earlier? Yeah. So here, you need to remove the standard plastic brackets. There's two plastic brackets here that come with both AM4 and AM5 motherboards. So you have to remove those before you install your Thermalright CPU cooler. Then to install, you put in the red spacers on the four like screw holes, 4 pegs on the 4 corners. And then you put in the two metal brackets. So the metal brackets are formed in this way, are designed in this way, whereby it is the bent part is facing towards the CPU. Okay, so as you can see, the bent part here facing towards the CPU. Yep. So yeah, so the distance on the brackets you will kind of clue you in that it is located top and bottom. Okay, so I'll just screw in the 4 screws evenly. Okay, so once those are in, then we will install our CPU tower cooler. So CPU tower cooler, you just the orientation doesn't matter. You can install it any way you want, but the screws, these are the only 2 ways to line up the so-called the retention screws. So there's a screw here on the CPU tower cooler. There's a screw here, a screw here, and a screw here. So you need to screw in those 2 screws. Okay, so I do it in a cross tightening fashion. So I do a few full screw threads on the top, and then I do a few screw threads on the bottom to ensure that the heatsink sits as evenly as possible. Yep, onto the CPU. And then moving on. So next up we attach the fans. I believe this, since it's just a boot test outside of the case, I only attach 1 fan most of the time, because 1 fan is actually enough to cool the heatsink. Sometimes you don't even need to attach fans to the heatsink at all, because the heat pipes actually do a pretty good job of taking heat away from the heatsink if we are not putting it under load. For example, if it's just a simple boot test, actually, yeah, we can actually skip putting on the fan. But I do like placing at least 1 fan, because when the fan spins, it's an indication that the motherboard has power. So yeah, if other than that, I have to rely on like signal LEDs on the motherboard itself to sort of know that whether the system is powered on or not. Okay, so skip forward if it's not too important. So just some house cleaning, skip forward. So now we're going to install the power supply. The power supply, I can't remember what we chose, but I believe this is a CoolerMaster. I can see the logo here. It's a CoolerMaster, and it is probably an 850 watt power supply, because we don't need too much. We don't need 1000 watt. It's way overkill for this system. And 850 watts should be enough if he plans to upgrade his GPU. Like if the client actually wants to upgrade to maybe NVIDIA like 70 series GPU or something in the future, 850 watts should suffice. The 80 series GPUs from AMD or the 80 series GPUs from NVIDIA probably would need a little bit more voltage, but 850 watts generally should suffice even for 80 series card. Okay, so we take out the necessary cables. Yeah, so okay, we have the name of the power supply here when I close the box. So this is the CoolerMaster MWE Go 850 watt V2. It's a fully modular power supply. I believe the cost is pretty reasonable, probably around 100 plus. It's not super cheap, but I think I did check the rating. It was at least a tier C or tier B rated power supply. And for this this class of GPU, it should be pretty safe. Like a tier C or tier B should be fine. As long as you're not buying anything below tier C, like tier D or below, they should be fine. Okay, so I'm just explaining how the 24 pin is to be connected. So for this particular power supply, the cables are in an interesting orientation. They have a split cable that is connected to the PSU, and then the 24 pin will connect to the motherboard. Yep, so the split one connects to the power supply, and then fast forward a little bit more, then we connect the 24 pin. Yep, so I bring it out on the box because, yeah, we're gonna press down on the motherboard, so the box will act as a little bit as a cushion and padding to protect the components on the underside of the motherboard. So I don't want to press it against a hard surface like the table, or even though the table is wooden. And obviously we need to connect the EPS power cable as well. So EPS power cable will connect to this top part of the motherboard. So there will be a 6-pin or 8-pin here. In certain motherboards, you have a dual EPS socket for like higher end, for more power delivery. If you want to like do extreme overclocking, for example, you want to get a lot of power fed to the CPU for extreme overclocking. So those motherboards with dual EPS power will be support that additional voltage. So in this case, this is a pretty basic entry-level motherboard, not too expensive. I believe the motherboard, like this motherboard along with the 7600 CPU, I think costs less than 400 if I'm not wrong. Or 400 or like 390, 380-ish. So it was a pretty affordable combination. So EPS power in, then the other plug will plug into the power supply. Okay, so we have power. Then let me fast forward a little bit more. Okay, so we shifted the camera and the table closer to the client's work desk because he has a power socket here on his work desk, and I needed to plug in the power supply, so we shifted it over. Okay, so I'm trying to do a boot test without the GPU because for the 7600 CPU, it does come with integrated graphics. And what I'm trying to do here, maybe earlier, let me showcase here. What I'm trying to do here is to just use the tip of the screwdriver, which is metallic, to kind of short the so-called the front panel power connector. Because notice here, since we don't have a case and we don't have those like the front panel like wiring connected, there's no power switch. So since there's no power switch on this particular motherboard, on the low end motherboards there's no power switch. How do we switch it on? You have to like short out the so-called the power pin on the usually the bottom right hand corner of the motherboard. Take note that the motherboard orientation, now this is the top part of the motherboard, and yeah, so this is facing the front part of the case. Like the case will be something like this, right? The GPU will be slotted here. So so this is on the bottom. So in this case, this is the bottom right hand corner of the motherboard. So usually the front panel pins will be located, or the power pins, the hard disk activity pins will be on the bottom right hand corner of the motherboard. So there will be two particular pins that you have to short out in order to power it on. And what are those pins? I would say refer to your respective motherboard manual. Most of the time, motherboard manuals should be available online. You just use your smartphone, go to the respective website. In this case, will be ASUS website. Look for the model of your motherboard, and there should be under support category, there should be a motherboard manual. So you can download the manual. If for any event they don't provide any physical manual, you can refer to the electronic manual, then just refer it on your phone. Look out for front panel LEDs or front panel connectors, then they should show you which pins are for powering on. Okay, so we power on, and in this case I didn't shift the camera, yeah, because I just didn't want to like accidentally capture the client's face and stuff like that. So but it did power on successfully. When you power on, oh yeah, so I'm taking, I think, the HDMI. So the HDMI cable from from the monitor has to connect to the motherboard in this case, because note that we don't have a GPU connected yet. So in this case, the display out is actually from the integrated graphics on the 7600 CPU, and we connect it to we connect it to the motherboard. So here we need to connect the mouse and I believe the keyboard as well. Then yeah, so we think connected a keyboard, and then the HDMI cable from the monitor has to connect to the back, the input output side on the motherboard. Then here I shot it again, and I believe the boot test went successfully based on my memory. I didn't show the screen. I forgot what I was saying. I was telling the client here. Yeah, so we connected keyboard and as well as the mouse, and I think I did some settings. If I'm not wrong, I believe I went to set up the expo timings on the memory, and just to check whether the motherboard detected the NVMe SSD, because we haven't installed Windows on it, so obviously we can't boot into Windows. But yeah, so based on my movements on the keyboard, I'm probably doing some settings on the BIOS because it did successfully boot. And you can see that power supply fan is spinning. You can see that the power supply fan is spinning. You can see that the CPU cooler fan is spinning here in the video as well. Okay, so fast forward more. Okay, so now we gotta build it into the case. This is the Lian Lancool 207. Among the options, I gave the client a few choices on the cases. He actually chose the Lancool 207 because I think he wanted a bigger case with good airflow, which is a pretty smart idea. I actually suggested the Lian Dan 3, the Lian X Dan A3 MATX case because it's a small compact case. It's one of my favorite cases, but it seems like he doesn't want. Yeah, he's a bit afraid of not enough airflow to his parts, so he wanted a bigger case. And the Lian 207 has the best airflow. It's very well reviewed on sites like Gamers Nexus, and I don't know whether Hardware Canucks reviewed it, but Gamers Nexus I believe did review the Lian Lancool 207, as well as I think Gear Seekers did a review on Lian Lancool 207 as well. So you can check out Gamers Nexus channel or Gear Seekers channel if you like a full review of the case. But my general opinion is that the case is really is pretty good. Not super high quality because it came in at a price of around I think 90, I think 100 plus SGD, but it was I think below 120 Singapore dollars. So it is not super budget. It's not like 70, 80 Singapore dollars, that kind of super budget level. It is in the mid-range category, I would say about 120 SGD, and for the amount that we pay, it is pretty good because the airflow is fantastic. There's what I love is there's two GPU fans located like behind the PSU area. So the power supply is actually installed in front of the case, at the bottom front of the case, rather than on the bottom back of the case. We will see it if I reverse. Yeah, so we can see that this is the front of the case. This is the front of the case, right? Where airflow comes in. The power supply comes in at the bottom front, which is pretty unique because most cases the power supply is located at the bottom back. So Lian Lancool 207 has this pretty unique design whereby they intentionally place the power supply in front so that you have a lot of empty space in this area. I'll use blue here. You have a ton of empty space in this area to intake air. So there will be a mesh panel that covers the side here, and that will be for air intake. So two fans located at the bottom of this route here to blow air into your GPU. So it's gonna provide excellent airflow to your GPU. It's very rare case that the GPU will overheat in this case, unless you fully populate the bottom with junk. Obviously cables can come in here because power supply is here, so your cables can come in here. But you can, if you just use cable tie and keep the cable somewhat neatly managed, doesn't have to be super neat, there should be enough space for it to draw air from the side panel. Other instances whereby you could have less airflow could be that if you put in additional hard disk. I believe there is a hard disk cage location here, and if you put in additional hard disk, it could like impede the airflow. But if you don't have additional hard disk, this is an excellent design to get air to intake air to supply the GPU. Okay, So this is why I really like this case, because of the excellent airflow from GPU, and it also has excellent airflow for CPU as well, because two big, I believe those are 140 or is it 180 centimeter, 180 millimeter fans for the intake. I'm not super sure. And they are ARGB as well. So looks wise, it's not too bad. It's not the best looking case. Best looking case in my opinion right now would be the Fractal Meshify 3, which another one of my next clients is interested in buying, which looks absolutely gorgeous, but it's also, the price tag is not that gorgeous because it's pretty expensive, like 355 Singapore dollars for a fully RGB decked out Meshify 3. So compared to like this Lian Lancool 207 is 1/3 of the price of the Fractal Meshify 3 because it's at around 120 Singapore dollars. So yeah, for the functionality of this case is fantastic. So I really like this case. So I think I'm just installing the power supply, if I'm not wrong. Yep. I think so. Let me fast forward. Yeah, so we're putting the power supply in, then adding the screwing in. Okay, so power supply is in. Take note that there is this additional extension cable, because traditionally most people want to plug in their power supply cable to the back of the PC, back of their case. So there's this extension cable that runs from the side to extend the power supply socket from the front of the case all the way to the back. So you can see this extension cable right here, right? So this is where we plug in our power connector. Then these are the cables, so we put the okay, just make sure that the standoffs are in the correct position. So I think this is what I was telling the client as well. Okay, there are standoffs here, and so on, right? So these standoffs are in their default locations. If it's a MATX build, we will probably be using the standoffs. Probably this will still be used. So the standoffs or here will be used. So you might want to shift the standoffs from here to here and so on. So I just want to unscrew and shift the standoffs up. Usually they will, for most case manufacturers, they will include a tool for you to unscrew the standoffs. You will need to use your own screwdriver, but they have like a kind of like a cap for you to cap over the standoffs so that you can unscrew the standoffs from the case. Okay, so I will fast forward that. Yep, so standoffs arranged. Then we place our motherboard in. So I think this, I mentioned it in one of my shorts, is that I prefer to keep the power cables connected to the motherboard. So since we already did the boot test outside of the motherboard, right, I don't remove the cables from the motherboard, because this makes it a lot easier when you have the 24 pin as well as the EPS, especially the EPS power cable already connected on the motherboard when you try to install the whole motherboard into the case. Because after you have installed the motherboard, and if you try to route the EPS cable as well as the 34 pin to connect to the motherboard, it really gets a bit harder because of some power supply cables are not as flexible, some are not braided and things like that. So it depends on the stiffness of the power cables. It can be pretty difficult. So you can see that my EPS cable is already connected. Maybe let me reverse a bit. Yeah, so here you can see my EPS power connector is cable is already connected, and my 24 pin is already connected. Okay, so just fast forward this a bit more. It's just some screwing in of the motherboard. Personally, I don't think it's necessary to secure all the screws on the motherboard. I think I was explaining this to the client. I believe as long as you have at least 4 screws for your motherboard, it should be fine. If you're running a full size ATX motherboard, maybe 6 screws. I think if you populate all the screws, it is about 8 to 9 screws for the motherboard, which is a little bit of an overkill in my opinion, because for most people, you're not gonna be shaking your PC case around, right? Because you're gonna keep it stationary in your room. So as long as it's secure, like 4 to probably 6 screws is enough to secure your motherboard to your case. Okay, so what am I doing here? Am I attaching the, what do you call it? Yeah, front panel connectors. Yes, if I'm not wrong, I'm attaching front panel connectors. Okay, so front panel connectors, I think, is that it? No, I think I'm still trying to screw in. Yeah, I'm still trying to screw in the motherboard to the case. Okay, so once that is done, yeah, so front panel connectors now, to connecting front panel connectors to the motherboard, I believe this is HD audio, which connects to, I think, the audio jack on the front of the case. And then there will probably be a USB connector. Then there'll be a front panel like power button and hard disk LED connectors. And oh, we don't get to see everything. This is, I think this is USB, front panel USB-C, if I'm not wrong. Yep. So front panel USB-C connects there. Yep, connects here. Most of the time it is at the side of the motherboard. Front panel front panel power button and so on is usually at the bottom here, and then HD audio is usually on the bottom bottom left hand corner of the motherboard. Okay, so we will fast forward that. Not super interesting. Yeah, connecting all these cables can be a little bit of a difficult task. You can see that I'm asking the client to help me with a torchlight, so he's using his phone as a torchlight because we don't get enough lighting in the room. Even though actually his room's lighting is pretty good because he has a overhead light similar to what I have in my room, but somehow brighter. So but it's still not enough lighting for me to see most of the exact pins on the motherboard. So I asked him to provide additional light by shining a torchlight. I think moving on in the future, I probably want to bring the ring light I'm using right now. Probably bring the ring light to my client's place for like remote builds if I'm going to build more PCs at outside of my own room to provide additional lighting. Okay, so power cables are connected to the motherboard. So now from the EPS and the 24 pin, I route it through the back of the motherboard. So route them through here, and then I extend them, pull them to the front of the case, the front lower end of the case where the power supply is connected, where the power supply is already installed and connected to the power supply. Let's move on a bit. What else? Okay, since we can't see much here, I believe I'm doing some cable management. Yeah, the camera doesn't catch it here, so I'm probably doing some cable management earlier. Okay, so I've connected and routed the two. You can see that here there is one cable here, another cable here. So these two are the 8-pin PCIe power for our GPU, which we will install now. I forgot which which model of 9060 XT that we bought, but I do remember it's a 9060 XT 16GB. If I'm not wrong, it's the XFX Swift. The same model of the 9070 XT that I got in my system, but in his case, he got the 9060 XT instead, 16GB. So it's the XFX Swift card, dual fan. You can see that I'm trying to remove the plastic here, which it's quite difficult to remove. So yeah, I finally managed to remove the plastic, as well as the plastic peel on the fans. There are two plastic peels here on the fans as well. Did I remove that? Maybe I didn't. I am not sure. It's a pretty simple looking card, but it cools well, because for my XFX 9070 XT, the Swift edition, well, it looks decently nice. I bought the white version, but cooling performance is pretty good. So I have no complaints with the cooling performance. Also, I also have a bottom fan below my GPU to supply air. which really helps a lot. So in this case, this is why I really like modern cases that has two intake fans at the bottom to supply air to the GPU, because it really ensures that your GPU runs cool, especially modern GPUs like such as 5090s, which generate so much power, they have so much heat to dissipate. So this kind of cases are really good. Okay, so before you install your GPU, I think what I did earlier was I remove these two slots here. So the back of the case usually has so-called covers to ensure that the case doesn't come like fully porous, that the rest of the slots, the PCIe slots that are not used are being covered. So obviously we need to remove those that we need to use. So if I'm not wrong, this should be a dual slot card. The XFX Swift 9060 XT 16GB should be dual slot. So I removed two covers from the back of the case, and then we install our GPU as you saw earlier. GPU comes with just a single 8-pin, so doesn't require too much power. Like a single 8-pin is all that we require, which is a pretty elegant solution. So 9060 XT, yeah, pretty low power, doesn't need a lot of hassle. Definitely looks nice. It looks like the 16-pin design from NVIDIA, but 8-pin is really reliable. There is no risk of burning down as far as I know. Okay, then we screw in to attach it, and I believe this is the inbuilt GPU support bracket on the okay, let me reverse it a bit. Yeah, so this is the inbuilt GPU support bracket for the Lian Lancool 207. In this particular instance, I think we tried to utilize it because later you will see that we tried to unscrew it and shift it here, but it still couldn't reach this particular GPU because this GPU is actually so small that it doesn't reach the front of the case. So this particular bracket is really useful for if you have much bigger GPUs, probably like a 5080 or like 5090s and so on, and yeah, then it will be a really nice anti-sag bracket. So this is another like very nice quality of life feature for the Lian Lancool 207, and another reason why I like the case. So I think we tried to shift it in, and then we tried to shift it forward and realized that, oh, it still doesn't touch the GPU. Then we gave up and just leave it there. Because I told him that, yeah, the GPU is small enough that it probably doesn't need an anti-sag bracket. And he agrees with me, like the GPU is really small, like it, yeah, probably wouldn't sag. So you can see that we shifted. So the original bracket was here, we shifted over to here, but it still doesn't touch the GPU. So yeah, that's that. Well, technically he could buy an aftermarket GPU sag bracket and install it from here to like support the GPU here, but I don't really think he needs it because this GPU is pretty small, it's pretty light. Yeah, I don't think it will sag. Okay, so I think putting some final touches, I'm installing the second CPU fan. I think I'm explaining to the client how do you tell the airflow. So make sure that the air goes out. So maybe for the audience here, earlier I have, yeah. So for the audience here, how do you determine the airflow is that if you see the exposed blades on the fan, you'll notice that the blades come in like this. Yeah, it's curved this way. So the fans will spin this way. Fans will spin this way. Is it easy to see? Maybe shall I use red? Fans spin this way. So if the fans spin this way and the blades are located like this, it means this is intake. So the air will go in through here and then they will exit out here. So usually the exposed front part of the fan is usually the intake, but there are some reverse bladed fans which are bladed in reverse. So that means the fans will spin this way and the blades will face the other way instead. That is for them to like intake air from the back and then blow air out to the front. So yeah, so but most of the time the fans that we receive will be the normal orientation, normal fan direction, which is it will spin in sort of like a clockwise direction and it will blow air out the back. Yeah, how do we recognize? You really have to look at the angle of the fins. So if the fins are angled here and then it's sort of like angled down, you can see that it's here, then it's angled down. It means it's gonna slice air from the front and push air out the back. If it's angled the other direction, whereby the sharp part of the blades are at the back, and then the front part is where it's like it's really difficult for me to explain without a physical fan. But basically, you look at the slope of the fan. So it's sloping down here. That means air will hit the front part of the blades and being pushed here and then pushed back. Yep. So that's how you tell the airflow direction of the fans. Okay, so I'm explaining that it pushes air out the back, installing the fan bracket. So this is a little bit of a pain point. It sometimes gets a bit hard for the fan brackets to be installed. So you have to put in the fan brackets here and then on the bottom of the fan on both sides. So there are 4 holes which you have to thread the metal wires or the retention brackets through. But once you thread it through the installation, the next part is simple. You just pull it back lightly and it should catch onto the side of the heatsink. There will be grooves on the side of the heatsink for you to catch onto. And then the fans are installed. Then we have to plug the cables in to the motherboard. So obviously the fans comes with fan cables, so that you need to supply electrical power to the fans to make it spin, and they have to be connected at least to the motherboard or to a fan controller in order to get the fans to spin. Okay, so do some simple cable management there with cable tie to make the cables look kind of neat. And I tuck the cables out of the way, so maybe I reverse a bit. Yep, so you can see that here I do some, so I cut and then I arrange, tuck the cables sort of underneath the fan heatsink, or maybe beneath the the heat sinks of the motherboard, so that it gets out of the way. Yeah, so it doesn't look like eyesore. Okay, so in this case, GPU cables, I think, so just one PCIe power cable required for the GPU. Yep, so this is the side panel. So now that the power supply is installed, so we're installing back the side panel. So this side panel is grilled or mesh. So there's small holes on the mesh for it to intake air. So you can intake air from the side and then blow the air into the GPU. Okay, anything else? I believe that is that. So after that we did a boot test and we did installation of Windows and everything, which wasn't captured on camera because I didn't want to risk exposing the client's private stuff and stuff like that. So so that's it for the build. There's not much more else to this footage. So we will end on the last screen, which is where, so this is the part. So so once we connected this, this is the final build. Maybe I rotate a bit. So this is the final build, and basically it's a very simple sort of blackout kind of build. 1,500 Singapore dollars. Repeating the specs, I believe it's a CPU is Ryzen 5 7600 on the AM5 platform. GPU is AMD Radeon 9060 XT 16GB. The RAM, I believe, is 32GB DDR5, 6000 mega transfers. I can't remember the CL, could be CL32, could be CL30, could be CL36. Not super sure. I remember it was not a priority to go for the fastest RAM for this client because he wasn't that he didn't need the highest FPS, right, for the games that he played. He wasn't a competitive gamer. Air cooler was the Peerless Assassin Black. I think the Peerless Assassin SE air tower cooler only costs 42 or 45 Singapore dollars. You can see that I think it's non-RGB, so black. Case is the Lian Lancool 207, which is an excellent case, and all the parts selected were black along with the case, along with the fans and so on. So it's a pretty blackout build. There is some RGB here, so RGB on the front two fans. Other than that, none of the other parts are RGB. The XFX logo will light up around here. I believe it lights up in white. There's no RGB to that, just a white logo on the XFX lighting. Then no other RGB on the case. Even the RAM sticks, I believe, are all blacked out as well. So yeah, for this particular client, he didn't really require our RGB aesthetics. He's fine with a blackout build. So this case as yeah, it suits his taste fine because minimal RGB. All right, so that's it for this 1,500 Singapore dollar gaming PC build in the Lancool 207. If you have any questions, feel free to pop it down in the comments below, and we'll see you guys in the next one.